Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So today I would like to continue something that I started on the previous stream, which is re-implementing Raylib in JavaScript. To be fair, the goal of the project is not as ambitious as it sounds, right? So essentially, for those who doesn't know, Raylib is a game library, right? So, and it's written completely in C, so it's for writing games in pure C. And I was not particularly satisfied with the way it is ported to web. There's nothing particularly wrong with the approach they use. They rely completely on scripting, right? And it's sort of like a cover everything approach, right? So essentially mscripten just like literally re-implements the entire POSIX layer, which makes it super quick to port existing POSIX applications to just web, but the end result is very bloated and very janky, right? But if you don't care, it's fine. So unfortunately, I do care, right? And what I decided to do, is to see how difficult or easy it is to implement a small subset of Raylib API in JavaScript, so you can use it directly from WebAssembly written in C without mscript. And for more context, I really recommend you to watch the previous stream. The link is going to be in the description, right? So there's the full context in there. But what essentially this library facilitates, will try to facilitate. It's not even well implemented yet. There's not that many things implemented there. So what it facilitates the sort of like this simple style of C programming for WebAssembly without mscripting. So this is a style of programming of its own, right? So it's not really that well known, but it's a very cool style which results in a simpler and, in my opinion, more maintainable software because it doesn't depend on too many moving parts that can break at any point. Right, so if you want to learn more about this kind of stuff, I recommend Googling up C WebAssembly without mscripting, right? And so there is one article, like a really good article that basically summarizes how you generally do that, right? So, and I'm gonna give that article to people in chat, and of course people on YouTube who's watching on YouTube. I'm gonna put it in the description. Of course, it's gonna be there. So let's take a look at what we've got so far. So essentially, we've got a very simple game, right? It's written in Raylib. It is compilable with Raylib. So I think I actually removed the Raylib library from here. So let me quickly maybe bring the Raylib library back so I can actually demonstrate you that this particular game is actually native, right? It is actually native. So you can run it on a native machine. So this is going to be game, and the game depends on game C lib raylib.a, which is this thing, and then we do clang game game.c, not gaming, game.c. And essentially we're going to link with Raylib and what's going to be the next thing, so the math library. So this is one of the things we'll definitely need to have in here. Let's try to compile this entire thing. So it's compiling for web, right? So it compiles it to WebAssembly, but it's not that interesting. And Raylib header is not found, so let's actually add include path called include, right? And I'm going to rebuild probably only the game. Right, so it could not find the library. This is because we need to add a library path. Hopefully now it found the library, and if you try to run this game, so you have the bouncing circle, right? As you can see, it's a native application. It's a native application that doesn't in fact work outside of the browser. So, and there's a second compilation line which compiles this entire thing to WebAssembly, right? If I do game.wasm, right, game.wasm. So this is not really what I want to do. I want to do making here instead. It's already up to date, right? So, and what it does, it generates this Wasm module. It's actually a very small Wasm module. It's all like less than 2 kilobytes, right? Just less than 2 kilobytes. On a scale of web, how much is that, right? So we have hello worlds that are measured in megabytes. And essentially what we did, we looked through what Raylib functions we use in here, right? Things like begin drawing, clear background, and stuff like that. And we literally implemented them in JavaScript. Right, so we literally implemented them in JavaScript. So here is the list of these functions. So that C program compiled to WebAssembly will be calling to these JavaScript functions. Right, so the game doesn't really know where exactly it is running. It doesn't know where it is running natively in Linux or on Windows or in a browser. It literally has no idea. Right, so and now we have to start the server, right? So because if you're fetching WebAssembly modules, you have to do that through a server because of the course, like, you know, restrictions and stuff like that. So it's going to be HTTPS server 69 or 69, and we're going to go into localhost. Look at that, and it is working there. It is working there. And we're not using the official Raylib web support, and we're not using mscripting again. And we managed to implement that, I suppose, within like 2 hours on the previous stream. I think it was like around 2 hours. The whole setup and everything, prototyping, and it now works in there. And the whole thing, right, so the library itself is 3.5 kilobytes, right, a small subset of Raylib. So the game itself is 2 kilobytes, and HTML is just like 359 bytes. So the whole thing. Right, so I really like these simple things because they don't have that many moving parts. So people quite often like don't understand why I care about complexity or simplicity of the application if you can just add a little bit more bloat and get to the market faster. That's the argument I constantly hear all the time. So sure, I'm not a market person. I'm a software engineer, first of all. I'm a software engineer, and I devoted my life to making software systems. And here's an interesting thing. The part of software engineering is also planning software development. Here's an interesting thing about simpler systems. The simpler the systems are, the less moving parts they have, the more predictable their development will be, because you will have less problems that you do not anticipate. You may have like a fair amount of problems. You may have a fair amount of problems that may scare away some people. But what if all of these problems are predictable? Think about that. So imagine you have a fair amount of problems, but each individual problem is solvable and predictable. Think about that. That is actually super cool because now you can plan it. But now, like if you are going into more complicated systems, now you have, first of all, a known amount of problems, and you can't predict them. You can't plan them. So it becomes more difficult, more frustrating, and maybe even more expensive over a long time. It would be interesting to do some sort of research on that. I don't know. But yeah, as a software engineer, that's why I care about simpler systems. They are maybe a little bit more difficult to develop perceptually. It may feel like they have more problems, but if each individual problem that you encounter is actually predictable and you can account for and predict that it will happen, you can plan. And now the whole thing is actually controllable. You are in control of the project. Where if your software depends on a shit ton of different libraries and different APIs, each of them can break at any point, you are no in control of anything. You can get fucked up at any moment. So yeah, that's basically my sort of view on software development, essentially. That's sort of my view. Anyways, so, and what I'd like to do today, I would like to take some of the official Raylib examples, and try to port them to Raylib.js. Right, it's probably not going to be possible because Raylib.js implements, again, a very small subset of the API, but that's going to be an opportunity to actually extend the implementation of the API, if you know what I'm talking about. Right, so we're sort of like treating this entire source code as the model, and we're using examples as the training data set, and we're doing gradient descent manually. Yeah, that's kind of interesting. And this is kind of funny because I think if we're going to be having like an AI that actually code, right, that actually does a good job at software development, I think it's not gonna be a language model, right? A pre-trained language model, because software development by its nature is training a model, right? It is training a model. So the thing that codes must be meta optimizer. That's what it needs to be, right? Because I said that multiple times that in software development, your code is the model like machine learning model. Your requirements is the data on which you're training that model, and you are the optimizer. You're manually doing recursive descent to weaken the parameters of the model so it fits the requirements. So if we're going to have a thing that codes instead of humans, it's going to be this optimizer. So essentially you can think of gradient descent as the coder for a very simple model of of a neural network or something like that. All right, so I think that's the way to go if we want to automate coding in that regard. Right, but then we'll have to come up with a language that specifies the requirements for the meta meta optimizer to do. And how we're going to call this language that describes the requirements? We're probably going to call it a programming language, and people who write the requirements are going to be programmers. Anyway, so cheers. Software development isn't marvelous. So all right, let's go into Raylib examples, right? So let's actually go to the Raysama. So I suppose there is a lot of different examples for different sort of like submodules of Raylib, right? So, and the main module is called core. And I suppose that's what we're interested in. So we have a camera 2D. We have a camera 3D, core basic screen manager, core basic window. So there is a screenshot. Congrats, you created your first window. That's pretty cool. So, I mean, we already have an example that is more complicated than that. So maybe we can have a frame control. Maybe we can have a frame control. That is very interesting. So, Raylib uses this sort of like text rendering everywhere with its custom font. So maybe it is going to be very beneficial to actually implement a thing that does that, because it's sort of like the basic rendering of the text. So because of that, I think we should start with the core basic window, right? So that's what we should start with. Core basic window, and in here we have a thing called draw text and everything, so light gray. So GitHub, shut the fuck up, GitHub, get the fuck out of here. So I'm sorry. So, and yeah, let's go ahead and just download this thing. So this is the raw thing, and maybe we're gonna have examples, right? So this is an example, and I'm gonna download that example raw. I'm raw downloading that thing. So does it have a license? I suppose it does in fact has a license, right? But I mean, it has a copyright. I'll need to not forget to like add the licenses for Raylib. So these are the headers, right? And the headers already contain the license, I suppose. Yeah, here is the license. But I'm not sure what license is the examples. Oh, it's a BSD-like license. Examples under modified zlib, which is, okay, so the license is there. All right, so I'm not violating anyone's copyright, right? So I'm not stripping off anyone's name. So it's just like all of that belongs to Raysan. I'm just like borrowing it for my purposes. Anyways, so let's actually go ahead and try to implement the compilation. So we're going to have examples. And the first example we're going to have is core blah, 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 this thing. So core basic window. And the thing I want to do, I want to actually build it as a native application first to confirm that, you know, the entire thing right now compilable on my machine. So this is going to be that, and this is how we build the whole thing. Okay, so something doesn't work in here. So this is how we build the whole thing. I can even copy paste this entire stuff. Boom, boom, boom. So core basic window, there we go. So let me just go ahead and make that specific thing. So there's no such file because I'm a dummy dum-dum. I'm supposed to prefix this entire thing with example. So are you happy now? Yeah, I'm supposed to prefix it in here. Samples. There we go. So that seems to be working. That seems to be working. Core basic window. There we go. Can you see the text? Congrats, you created your first window. Okay, looks cool. Okay, looks cool. Now, flashbang. Yeah, exactly. Flashbang. So now what we need to do, we need to actually create a Wasm module of this entire thing, right? So I suppose it's going to be located in Wasm, right? So Wasm. And how we're going to be doing all that? I suppose I'm going to copy paste this entire stuff, and I'm going to simply replace game with core basic window. Actually, yeah, core basic window, core basic window, game.c, core basic window, core basic window. Okay, so now I'm gonna go ahead and simply build that specific thing needed by core.c. Oh, it's part of the examples, of course. I forgot to I did a fucky wacky yet again. So this one is also part of the examples. As far as I know, makefile has some sort of like you know, patterns, right? So which allows you to reuse some of the rules and stuff like that, but I don't know how cross-platform the entire thing is. Okay, so we managed to create a Wasm thingy, and here is the Wasm module. It's actually smaller than the game because it doesn't really do that much. Yeah. It's worse than regex. I do quite remember that. I kind of remember that. So so let's actually try to run this entire thing. Oh, by the way, somebody recently submitted a pretty cool pull request for Raylib. So I suppose I want to actually fetch that super quick and merge this entire thing. And don't know if it's going to be like a merge conflict, but probably not. Yeah, there we go. So there was no conflicts or anything like that. So essentially, what they did, they added a check whether we are online or not. And if you just open the thing from the file system, it will tell you just run it through the browser. So that's what they basically added. Right, so we can even take a look at how it looks like. Right, so if I do Chromium and I open it up like that, so as you can see, unfortunately, due to course restriction, the Wasm assembly cannot be fetched, do blah, blah, blah. Just do that if you want to run it. Right, and if you open it in here, right, so it is working. It is, in fact, working. So let me actually open DevTools and refresh this entire thing. Right, just to make sure that the cache is updated. And yeah, so I also recently fixed a thing where you just switch off from the thing and go back, and it doesn't go, you know, crazy. So the reason why it was going crazy when you switch between the tabs is because you know, the scheduling of the frame stops, so the animation cannot continue working. Right. So what they do is that we just don't allow delta time to be super big, and we effectively skip the frames, right? So effectively skip the frames if it's too big, right? For now, for demos, it is fine. It's a sort of like a stopgap solution, right? So, but maybe in the future we're gonna come up with something better. To be fair, I feel like this approach is not going to replace Raylib completely. It is not going to replace Raylib completely, but it's going to be for the situations when you care about the simplicity of your setup and you don't use the entirety of the Raylib, because I don't believe that we can implement the entirety of the Raylib using that. Right. So essentially you have a simple game that you want to quickly port to web, right, and you don't use anything, like you use only the APIs that we implement in here, and you can just slap this thing in here and it kind of works. And I also want this thing to be super simple and minimal and hackable, to the point that the way to use it is just copy pasting this JS script and maybe even hacking it and just adjusting something there, right? So I really like these kind of libraries and these kind of systems. This is one of the reasons why I like Raylib itself, by the way. Raylib is one of these things which you can literally copy paste into your project and modify something in there, and also STB libraries, right? So I really like this kind of approach to the libraries, where the whole setup is just copy pasting a single file, and the file is so goddamn simple. You can look into it, you can read it, you can fully understand it, and maybe modify it according to your needs, right? So because that way you become in control of the dependency. So why is it important? People quite often, like newer developers, don't understand why it is important to be able to modify your dependencies, because you take in control over them, right? And if you control your dependency, you can plan, you encounter less problems. So in enterprise software development, we call it vendoring. Yeah, I know that. I worked in enterprise software development. So people often think that I am the way I am because I never worked in enterprise and don't know how the real world works. No, my friends, I am like that precisely because I worked in enterprise. Precisely. I'm fucking telling you. So alrighty. Alrighty. So let's maybe go ahead and try to run this application, right? So the example in Raylib. So the problem that we have right now is that the game is hard-coded, right? So how do we fetch that? So here is the fetch, and as you can see, it is in fact straight up hard-coded. Right, if I go to here, right, so where is the Wasm? Let's quickly replace this Wasm module and see if it's going to work, right? So I'm gonna go to the consoles and I'm gonna refresh the whole thing. Right, so yeah, this is the first thing. To be able to use Raylib.js, your application has to be organized in a certain way, right? It has to be organized in a certain way. So essentially, you have to export three functions: game frame, which renders the single frame, game init, and game over, right? Game init initializes the game, it does init window, and blah, blah, blah. And then game over, you know, finalizes the window. And right, you need to have this kind of thing. Right, so essentially for the native part, you are organizing the loop yourself, right? You organize the loop yourself, and in the web, the loop is called for you, right? So by the system. So as far as I know, like mscripting version of Raylib is capable of using something called Asyncify. I wonder if at some point we'll manage to implement something similar, so you can just like straight up compile the thing as it is. So maybe make something similar to mscripting does a set main loop thing. I'm not really sure how exactly to do that with the current approach, right? So because we're going to be passing the pointer to a function through to a JavaScript. So how exactly is it going to work, right? So that's the interesting question, right? So I'm passing a pointer to a function to JavaScript. How JavaScript is going to see that at all? I have no idea, honestly. I have no idea. We can try to maybe see that, right? We can try to see that. So essentially, I'm going to say that I expect from JavaScript to have a function something like set entry, right? So, and it's going to accept a pointer called entry, which is just a pointer to a function, right? And in here we can have some sort of an entry which maybe does something, right? Which maybe does something and maybe calls to another function, right? Something like print message, right? Const char message, and we can say something like hello from entry, hello from entry. So, and essentially in game init, what we're going to do, we're going to do set entry, right? So, and the thing I want to do, I want to see what exactly entry is going to be from the point of view of, you know, of JavaScript, right? So from the point of view of JavaScript, so we can try to compile game.wasm, right? So let's compile game.wasm, right? So let's go through the compilation errors, of course, right? So that's quite important. Okay, that seems to be working. So let's go to Raylib.js and replace the Wasm module back, right? So this is going to be game Wasm, and let's refresh the whole thing. So set entry point returned 1. It literally returned 1. But that's not the whole story, honestly. I do not believe that this is a whole story. We also need to take a look at the module that we've gotten here, because maybe now the Wasm module imports some interesting tables. So essentially, in Wasm, there is a thing called tables. Right, this is something that I never used in WebAssembly, but they're there. And as far as I know, tables hold pointers to functions or something like that. They're pointers to functions. So let's actually go ahead and just console log Wasm and see what we have in that Wasm module. Right, so does it have any right module? Okay, so there's tables, right? So this is exactly what I'm talking about, right? So tables. But I suppose we are interested in exports in here. So there is a memory, game over. Okay, not that important, I suppose. Table 0. And okay, in one of the tables with index 1, you have a function which has a value. And we can try to go into the Wasm module somewhere there, and it is entry. It is the entry function that we just implemented, which calls to print message. So I suppose the pointer to the function in WebAssembly is an index in the table of functions. And again, I never used tables in WebAssembly. So this, everything I say right now is hypothesis on how exactly it works, but I have no idea how to access the tables, right? So this is an instance, and what is this shit? Like, how do I access these things? So right, WebAssembly instance get tables. A symbol, maybe a symbol, I don't know, whatever. How can I create? Okay, so WebAssembly table. WebAssembly table is an object in JavaScript, so construction WebAssembly table. All right. So yeah, you can do get instantiate streaming. So here is your WebAssembly instance. This is an object, and you can just literally do get 0, get 1. Get 0, get 1. So all right, after we did game initialization, a set entry function was called, right? So essentially what we can do, set entry, and we can do the following thing. So entry, right. So we may essentially do the following thing: let entry function undefined. So entry function equal to entry, and then in here we can say entry function was set to entry function, right? So that's essentially what we want to do. And afterwards we are going to do w instance get entry function, and let's simply print it, right? Let's simply print what this thing is going to be, right? I just want to see how it's gonna look like. Now let me see. So entry function was set to 1. Get is not a function, so you can't just do get. Table. Wait. So this is obj but then TBL. I'm confused. So exported assembly functions. So I need to probably read what the fuck this means, because this is a weird code, right? So we get OBJ, but where do we get TBL from? Do we get it from somewhere else, or what? So we create a new WebAssembly table, initial 2-element function. But OBJ is the table. But I literally did that, and it says that no, I'm sorry, it's not the case. Oh, I see. So that means it's not part of the instance. Okay, JavaScript. Get is not a function, right? So it is not the case either. It is not the case either. So OBJ, TBL, no. Oh, table is located in a separate Wasm thing? I don't understand how this works. Oh, Jesus. Oh my God. Then we create an import object that can import object. Ah, oh my God. Oh my God. So I see. This is kind of element any func. Sure, that's basically what we have to do in here, right? So that's basically, and it's not really part of the environment, right? I see. So there's also JS, and it's passed during the instantiation, right? So because you have an environment, and you also then do JS. You also do JS. Why does it have to be so convoluted? Why is it not just instance table? Like, why? There's literally no reason to not do that. So dumb. Right, so this is a table, and okay. So, and I suppose. So I also have to specify the initial sort of capacity of the table, which is also kind of weird. Like, why? Why do I have to do that? Like, dude, you already have a table. So this is so bizarre to me. You already have a table. I can inspect it in console, in web dev console. You already have a table. Fucking give it to me. Like, why do I have to go through all these hoops? It's so bizarre. I'm probably doing it wrong, right? There must be an easier way to do that. There must be, because it's fucking moronic. It's the most moronic thing I've ever seen. It must be different. It must be simpler. It's just like, what? Okay. So now we can just try to do table. We can try to print the table, right? So we can try to print the table. So, yeah. Okay, table is that. And table is null, right? So table is completely null, and it doesn't contain anything in there. So that means it didn't work. So yeah, I specified the table in here. I put some stuff in there, and doing it like that didn't work. Or did it? You know what? I want to make a small break. I want to make a cup of tea, because this is bizarre. This is bizarre. Okay, let's make a small break, and I'm gonna refill my tea, and we're gonna continue working on that. It's just like, dude, you already have a table. I can see the table in DevTools. Fucking give it to me. That's it. End of the story. No. All right. So Alright, so people suggested a very interesting thing off screen, right? So to essentially try to do export table, right? So maybe the linker doesn't export the table, and that sounds reasonable, actually. That actually sounds reasonable. So let me go ahead and simply try to do that. So we have already a lot of different linking flags, and I wonder if this one is going to work. Right, so I'm going to make And come on, it's not up to date. Please rebuild it. Thank you very much. And it didn't compile. So the linker actually understood that flag, which is perfect in my opinion. Okay, so this is a table. I don't care about this thing. So let's go to Raylib. Let's get rid of this entire stuff. And let's print the instance one more time. So here is the module, here is the instance. What do we have in exports? And in there, that's exactly what I wanted. That's exactly what I wanted, right? So a very simple thing, right? So indirect function call table. And here it is. This is the index 1 and everything. And I don't even need to maybe save anything additional, right? So create anything. Okay, so that's fine. So we initialize this thing, and that means I can now do instance exports indirect, right? What was it called? Indirect function table. Indirect function table get entry function, and right, so this is basically entry, and then I can call that specific function. So, and now if I do that, it tried to call print message. But we don't have such thing implemented here, so we can go ahead and implement it. So, and in here, obviously, we're gonna have a message pointer. Right, and how do you get the pointer? So there's a sister by PTR, So first you have to get the memory buffer, then essentially get the message PTR, and then we can essentially console log this entire thing. And if we well, I didn't really have to recompile, but if I refresh, it says hello from entry. So yeah, that's basically how you operate with function pointers in WebAssembly, through the tables, which makes sense, right? So, but you should not forget to export the table. And I'm actually quite surprised that the table is not exported automatically, because so funnily enough, I don't have to say that the memory has to be exported, do I? Right, so I never said explicitly that the memory has to be exported. The memory was just exported. So though I had to say explicitly that these functions has to be exported, it's kind of hard to tell sometimes, right? So it exports some things, it doesn't export other things. But maybe memory is something that always has to be exported or something like that. So this could be an approach, and is it even a useful approach for us? I'm not quite sure, right? So I'm not quite sure. Okay, so we set some sort of an entry point. Okay, so that means that doesn't really change anything that much, honestly. Doesn't really change anything that much, because we're gonna just replace this loop in here, right? So we're gonna be just replacing this loop in here, and if it's a web, right? So if it's a web, we're gonna just do set entry game init. Well, to be fair, not game init, but game frame. To be fair, we could have just now inlined all of these things. All right, we can now just inline all of these things. Like so, right? So this is that now. So the game over could be part of this thing, right? Part of the native part, and we can actually do it like that. So what's funny is that in case of a web, you never kind of finish. You never kind of finish, so probably it doesn't really matter anymore. So yeah, you kind of get rid of all of these things, and that means you don't have to even export any of these functions, right? You don't have to export any of these functions. So we can do maybe game frame. I just, for some reason right now, I want to follow the convention of Raylib, right? The Raylib uses like a camel case, right? It uses the camel case, and in here, how can we call it? We can say Raylib JS set frame or set entry. Let's call it set entry, right? So it's a special sort of thing, right? So if you're on the web, you just do that, game frame, and maybe that is better. Maybe that is even closer to like how mscripting works. So, and essentially, what we're supposed to do in here, from the point of view of Raylib.js, is to call main once which will just set up the game frame thingy, set entry, and that is it. So then we can continue running this thing. Now this looks like I'm scripting, but without the pain. Yeah, there was a little bit of a pain with tables, right? There was a little bit of pain with tables, but apart from that, it's actually super close. Maybe that is better. Maybe that is better. So f.dev platform web. Yeah, probably. I forgot. Just a second. If dev platform web. Okay, so let me try to maybe compile this entire stuff. I'm going to simply compile, you know, game, native version of the game. So it complains about some things. So it's a frame, game frame. And if I run this entire thing, is it going to work? Yeah, it does in fact work. So that's pretty cool. That's lovely. But we do need to import one thing in here. So export, I mean, we'll have to export main function, right? So we export in the main, but we don't care about game frame, game over, or anything like that. We don't care about any of those things. So now I'm going to try to compile the Wasm version of this thing. So it's going to be Wasm and Wasm. Boom. And I didn't want to run it, I just wanted to compile it, and it seems to be compiling. Okay, let's go back to here. Game init is not a function, right? As you can see, because we don't export it anymore. That makes a lot of sense. So now, instead of doing that, we have to do main only once. And the function that is going to be called is going to be Raylib.js set entry, and here is the entry. And we have entry function, and we have this thing. And basically, instead of calling game frame, we can call this entry thingy. And that should be actually, yeah, that's it. So that was it. That was easier than I thought. Okay. So, yeah. Now it is very close to the mscripting version, which is kind of cool, right? All right. So we probably don't need the print message. We'll need to have some sort of a login functions exported. I don't really want to use extensions, GCC extensions and stuff like that. I'm just like, Okay, so let me see what's going to be the next thing. So we have core basic window, and in here, right, and in here, we just need to factor out the thing. So let's do game frame, game frame void, and move all of this stuff to the game frame. Boom. And let's remove 4 in here. So I'm trying to not modify the code too much. If defined platform web Raylib.js set entry game frame, otherwise do this thing. Yeah, this is actually minimal modifications to the original, so yeah, that's actually really cool. Just to move the frame into a separate function, and it's going to be like as usual. Essentially. Now I can try to do Wasm core basic. Let's try to recompile this entire thing. Raylib is unknown, so game C. One of the things we have to do, we have to bring that stuff in there. Okay, so let's put it maybe somewhere here. All right, so that seems to be compiling. Raylib.js, so game Wasm core basic Wasm. So let's see how we can do this thing. Main is not a function, right? Because I forgot to export this thing. So how do we do that? So we are exporting everything except the main. Right, we're exporting everything except the main. So this is main, and this is game init. All right, and let's see. There we go. So undefined properties, and we don't export the table. Right, so now I know what we have to do in here. Okay, look at that. So how can I stop it, by the way? All right, so it rendered the thing correctly, right? It rendered the thing correctly. It would be kind of cool to maybe stop the execution if any of the error has happened in here. Right, but if error is happening, for instance, when you're trying to access something that doesn't really have a thing, instead of doing the error, like console error, we could have done maybe something like new error and just throw this thing. Is that a good idea? Right, I kind of like the fact that it would show everything that we don't have. Right, so yeah, maybe we could have like some sort of a boolean. That sounds good. But maybe the exception is going to like stop the execution. Let's give it a try. Right. So I'm gonna go to here. I pressed DevTools. It's taking so much time to open up. I don't know what the fuck all of that. Run ads. All right. Okay, so that seems to be that's a good idea, right? So not implemented, draw text, and we can even go here in a place where that happens. That's way better. Just throw an exception. That's definitely the JS way. I mean, it's not about like philosophy or approach, right? I liked the fact that I could see the entire list of all of the functions that I need to implement. Here, I see one function at a time. So yeah, so it's just like about like actual practical benefits. So draw text. Let's go ahead and implement that. Though also, the text doesn't contain enough useful information. I wonder if I can do something like this. All right, so this is going to be a prop, right? Prop, and then take a look at the args. I just want to see the args, right? Because this is very useful. So these are the arguments, and I don't remember what they are honestly. So Raylib include raylib.h draw text. So where's the function draw text? Aha, so here it is. Might as well, by the way, copy paste this thing in the draw text. So we didn't implement it yet. Let's go ahead and implement it. Draw text. So and in here we're gonna have a text which is a pointer, position X, position Y, font size, and color. And by the way, do we have a function that extracts the color by the pointer? I think we should have it, all right, because that happened several times already, specifically in clear color. So it would be nice to just factor out this entire stuff to a separate function. Right. Get color from memory. Get color from memory. And in here, so we're gonna have a buffer, the memory buffer, and so we just return that. Now, if I try to do that, get color from memory, and just pass the pointer, right? So we also have ptr. So color ptr. And on top of that, we can just put it in here, and that's it. All right. All right. And so the color, the background color was set up correctly, and draw text doesn't really complain, and the loop continues actually, right? Since it doesn't complain, the loop like continues doing things. So we have to draw the text with the Raylib font, but we don't have a Raylib font yet. But we want to draw some sort of a text already. So let's go ahead and just draw whatever text with whatever font. Right, so canvas HTML5, draw text. So let's take a look at how you draw the text. So drawing text, web API, all right. So field text, that's definitely something that we'll have to do. So, ooh, yeah, boy. Okay. So maybe we're gonna just use the default one. And so what are the parameters? X and Y, and then we like max width and everything. All right, so this is a text pointer and sister from pointer. This is something that we have to do. So the buffer is Wasm instance experts memory, right? So we get the actual text that we want to render. So this is the actual text. Then we take the context, fill text, add text, and position X, position Y. Right, so we don't really set the font yet, but we will in the future. So let's go ahead and see how it's gonna work. So cannot read property undefined of experts. Instance. Okay, title PTR is not defined. Text PTR. By the way, is there some sort of like convenient linter for JavaScript? Right, I don't feel like using TypeScript in here. I would like to have like a very simple linter. Wait, isn't Stragger working on some sort of a JavaScript linter in C++? Wait, how is it called? Does anybody know? Do we have any Stragger viewers in here? What's the name of the thing he's developing? Maybe we should try it. It is ESLint, QuickLint.js. Let's actually take a look at this. Quick, is it checking types or like something? QuickLint.js. Because I saw that it's like super fast because it's implemented in a native language. Right, QuickLint.js, find JavaScript bugs. Well, I mean, that's probably what we want. So no types but syntax error. Oh, it's only syntax errors, right? But I don't know what's the scope of this project. Is an instant feedback as you code, find bugs in your. I don't really like the instance feedback as you code, as I code. I suppose I'm very old-fashioned, by the way. I feel like I'm very old-fashioned. So I like to just code for some time, like introducing errors and stuff like that, and not being told that I have an error. And then once I'm done putting out my thoughts, I compile everything or lint everything, and then I go through the errors like in a to-do list and fix them up. Right? I don't like to be reminded that I have errors while I'm in this state of flow. So, and that's why I don't use these like LSPs and stuff like that that constantly tell me that you know, there are some errors, because I don't want my like trail of thoughts to be interrupted. So, but I suppose this thing, it has like it's just a command line tool. I can just run it separately. So install CLI, install Vim plugin, yeah. Install CLI. So Linux Debian menu. All right, static Linux. All right. Okay. All the strokes for all the folks. I like that. Okay. So, and if I take a look at that, all right, so this is the project, and let's just unpack this into, I think. QuickLint.js. So there's a lot of docs and stuff like that. That's cool, that's cool. And bin, and this is executable if you take a look at the file. All right, so it is dynamically linked, but does it depend on anything? Okay. All right, so I already respect the unboxing experience, right? So he spent a lot of time to provide like a lot of different ways for people to install, right? So package managers, npm, if you're into this kind of stuff, right? And for people like me, he provided just like a download of the thing. So I respect that. That's actually very cool. So let's actually try to run this thing and see what it does. A quick lint and a bin, QuickLint.js. So expected file name. Okay, very simple, straightforward. Raylib.js. No errors. Yay! So I wonder if we can introduce some errors. What if I bring the title back? Would it caught that? It caught that. I mean, is it on GitHub? nothing much to say. It even caught an error that I had. So, yeah. I suppose I can recommend that. All right. So, where's the description? So let's continue. So we draw the text, but there is something weird going on. So with the fill text, it doesn't really fill the text, right? I don't see. So I suppose one of the things we have to do after we fill the text, we have to say fill, don't we? Or maybe we have to set up the font, right? Maybe we have to set up the font, yeah. So do you have to set the color as well? Maybe that's what I have to do. Right. Nope. So let's try to maybe put 0 in here. No. Okay. So you know what I'm gonna try to do? I'm gonna do console log, and I'm gonna just try to take a look at the text. All right. So this is gonna be the text. And so let's throw an error, new error. Stop. So it's not gonna go and continue doing things. So you created your first window. Yeah, that makes sense. Okay, so congrats, you created your new window. But I don't really understand. Maybe it's the same color as the background. Yeah, so I suppose what I have to do fill style and just set that to let's put black in here. Right, so let's put black in here. So, and I'm gonna just check that everything's fine. Yeah, okay, so I can see that. All right, so that's cool. So let's quickly get rid of the console. All right, let's get rid of the console. And now, yeah, let's actually extract the color. Get color from memory. I have an inconsistent style of naming, right? So that probably pisses off a lot of people. But I'm gonna fix it up later. Okay, I promise I'm gonna fix it up later. It's just like whatever. Color, get color from memory buffer, and we have a color pointer, right? So this is a color PTR, and that's basically it. So that's the color. We might as well actually directly, and that's fine. That's fine. And now if I refresh this entire thing, that seems to be working, but we also need to set the position X and position Y. Right, so, and there we go. Congrats, you created your first, not even first, but first, whatever that means. You created your first. Okay, that's pretty cool. No. So we need to somehow set up the font for Raylib, right? What kind of font does it use? Does it use like a TTF font, or is that like a bitmap font? That's a very interesting question. So we have to read the Raylib source code. Raylib. I think I'm gonna go into the visualizer. And I'm gonna find Raylib. So let's find the implementation for draw text. That was too much, I think. That was too much. Maybe I have to do something like this. Draw text, but maybe let's include the open parent. So we have a text. What's funny is that the implementation is inside of our text, so it's not even our core. But the example claiming to be the example of core, but they use the stuff from the module R text. Okay. Get default font. All right, so they get the default font, and I wonder, like, what is the default font? So if it's just a single TTF, right? If it's just a single TTF, maybe I can basically get it right. So default font. So, and what is the default font? So it just returns this thing. Is that a global variable? It looks like a global variable, honestly. Is it loaded somehow? Load default font. Okay, so that makes sense. And what do we have in here? Ooh, this one is interesting. Support default font. Mm-hmm. 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 You know what I'm thinking? Okay, so it unloads the image. It unloads the image. We can try to compile that to WebAssembly, actually. So it does the allocations and shit. Okay. It does. This is basically the font, by the way. This is basically the font, and this is sort of like the atlas, I suppose. It is directly defined here. Data generated from a sprite font image. This way we reconstruct font without creating large global variables. This data is automatically allocated to stack and automatically deallocated at the end of this function. Okay, so it does in fact fit into the stack. So it's 512 4 bytes integers. So we allocated 412, so 2 kilobytes on the stack. So can we use the image from somewhere? We can try to save this image to PNG, actually. But I don't know the size, width and height. What's the width and height of this image? So 128 by 128. Okay. So let me see. So generate. Let's call it font.c. Right, so let's put it in here. Let's put it in here. And so that's a lot. That's a lot, man. That's a lot. Right, so I'm gonna just put it in here. So it wants to do something like this. And we can probably take the STB image. Do I have STB image somewhere? I'm pretty sure I can just go to visualizer Raylib, src, external STB image right specifically. All right, and I can just put that stuff in here. To be fair, I would like to maybe create a separate folder for font because it's a little bit messy. It starts to become a little bit messy, so I think I want to move it there. Right, so we're gonna have that. And we can include STB image right page and then define STB image right implementation. Right, so STB image right implementation. And essentially, we can just say that STB image right. So I think it's STBI right PNG. Right, so we can do something like that. We can just do something like that. File is going to be font PNG 128 by 128 for the data is pixels. So this is in pixels, I suppose, and stride in bytes is going to be 128 multiplied by 4. Right, so we just do that, and we can try to compile this entire thing. Font.c. There we go. So that, what does it say? Pixels. It's not really pixels. It's default font data. Default font data. Yeah. Okay. Segmentation font. Wait, what? That is unexpected. So if you do, yeah, that's bizarre, isn't it? So that is not correct. That is definitely not correct. So something sus is going on. What was the function where we had that? Our text, right? So this was our text. So maybe this is not pixels, right? So this is not what I thought. 2 bytes per okay. 2 bytes per pixel. So it's not just a raw data. I see. It's not just a raw data. So you then reconstruct an image, right? You reconstruct an image, and then you load the texture out of that image. Right, then you generate the glyphs and stuff like that, so blah blah blah, the usual thing. Blah blah blah, the usual thing. It would be kind of cool to maybe compile this entire stuff to WebAssembly and just run it from WebAssembly, because it doesn't really depend on like much on the standard library, right? Except for the you know, for the alloc, right? So there's an alloc, so this is a calloc, and then it calls load texture from image, but this thing essentially just does the OpenGL thingy, right? Does the OpenGL thingy. Then, so another malloc, but I mean, we can just like implement a bump allocator in WebAssembly and use that, right? So just implement a bump allocator and unloading the image, right? So, and unloading is just freeing. It doesn't really matter that much. It really doesn't matter that much. So, yeah. To be fair, it would be way cooler if Raylib was on top of some sort of like an abstraction layer that I could just implement in JavaScript. I think it technically is. I think it technically is because Raylib recently introduced a thing called platform, right? So Raylib architecture. I remember Ray-san actually posted like an architecture thing, but I'm not sure if I can find that. So the architecture of the Raylib. Does anybody remember the architecture? Here's the architecture. Yes, that's what I'm talking about. So here's the game. So at the very bottom, you have OpenGL and stuff like that. And then the platform libraries. Then you have, this is outdated, by the way. This is outdated. So you have R core. Yeah. So there is no R platform anymore. If I'm not mistaken, now you have R platform in here. Right. Oh, here it is. So R core platform. R core platform. You have a GLW, SDL, web, DRM. So they already kind of have like a web, but I mean, so what do they do for the web? What do they do for the web? What do they do for the web? So platforms. So this is the web. How do they implement that? So initialize platform. If I'm gonna do initializing platform, so they still use GLFW, right? And GLFW is just like a compiled with them scripting thing. It's just simply compiled with them scripting thing. So they just use them scripting, so which is actually against the point that I'm trying to make in here. So there's even our core template. I think I even saw that. So basically you just create that, you just fill it in, and it's going to work. But it's not going to work for ours, right? Because our core, for instance, is on top of our platform, right? Our core is on top of our platform, and this thing already depends on the standard library. It's like our platform is not the only thing that it depends on. So our platform is not abstract enough for what I'm trying to do, right? It would be kind of interesting, like if it was fully, yeah, even our core is not fully on top of our LGL. So that's what's interesting. Even our core is not fully on our LGL. So we could implement our LGL on WebGL, and that probably automatically means that we, like, all of these things will work. That's actually rather interesting. Our textures also depend on STB image, but STB image could be, you know, compiled for WebAssembly as well, right? It could be compiled for WebAssembly as well. All right. So what's going to be the plan? So what kind of plan do we need? So I suppose for now we need to make the example work, right? So that's the goal. We just need to get the sprite sheet of the font, right? The sprite sheet of the font, and just use it to render the text. Just use it to render the text. So it's basically a bitmap font, and I wonder if the browsers just support the bitmap fonts, or do we have to like query things ourselves? That's an interesting question. But anyway, I would like to make a small break. And think about it a little bit. And after the small break, we're gonna tackle this specific problem. All right. So on the break, we discussed a little bit about the fonts and shit. And apparently, you can get the font, Raylib font, as TTF or WAF or something like that. The font itself called Grixel, and we can actually just get that. So we already lost that information. Yeah, so we already kind of lost it. So I would like to, but maybe we can just use the CSS that somebody posted. I don't know. This is kind of sus, right? This is kind of sus. I don't want to use that. I want to just like use that directly. So yeah, thank you so much, TTF. Thank you. Who needs ChatGPT when you have chat? Am I right? Who needs ChatGPT? So already, so we don't need this font. I'm going to remove it, but I'm going to create it again. That's how I empty folders. I just remove it and create again. And I'm going to just download this entire thing, wget. And we got the font. We've got the font. Next question is, how do we add it to CSS? CSS. So let me see. So as you can see, we're trying to hack a Raylib website, and we try to extract the font, right? So Ray-san, we hacked your website. We stole your font. Anyway, so CSS font. Hacked. Stole the font. Borrowed, yeah. Borrowed the font. Yep. So maybe I should have said custom font. That's probably what I should have said, custom fonts. I'm not a web developer, okay? I don't remember this kind of shit off the top of my head, right? I need to go to W3 schools, right? So that's what I need. Right, font face. That sounds like an insult. It's such a font face. So let's actually grab that. I think I make that joke every time I do fonts with CSS. So, and this is like a font. And another thing I remember is that this shit never works for me first try. That's what I remember, right? So we're gonna spend some time trying to figure out what the fuck is going on. Right, but I'm already kind of prepared for that. So I can actually rename it to fonts. And this one is not sans blah blah blah. This one is Acme 7. Did somebody just troll me? This is not Grixel, or is it? Well, I mean, it's a Grixel Acme something. I'm gonna just remember the person who's sent this thing. Acme 7. So it was no deref. Okay, it was no deref. All right, noted. Yeah, noted. So if it doesn't work, we know who to ban. Right, so I'm gonna copy paste this thing. And, yeah, boy. So Grixel. And when we are doing Raylib.js, I'm gonna just do Grixel, but I'm not gonna send font size. And I suppose what we'll have to do, we'll have to sort of put font size in here. Anyway, so let's continue. So trolling Zozin must be expensive. You should pay the price for trolling Dazozin. So let's take a look at the network. So boom. Okay, so it worked, kind of. It kind of worked. Yeah, it doesn't feel literally the same, right? I do agree with that. We can try to just compare that to core basic thingy. It's not really the same. That's bizarre. Why is different? This is because this was probably the original Y, and then Ray-san has changed it. So that's probably the situation in here. that's probably the situation in here. Okay, so now let's go and take a look at the console log, right? So this is going to be font size, right? So might as well actually do a pretty interesting thing. New error, error font size is this thing. So this is the font size. And then we're going to just throw that. So we want to throw an exception so it stops the execution of the loop, right? So we can see shit in this mist. So font size is 20. Okay, so that means we can just go ahead. And I suppose it is in pixels. It is in pixels. All right. Why did I fucking do that? That's so dumb. All right, all right, all right, all right. That didn't work. That's bizarre, my friend. What if I... Oh, yeah, I know why. Because I'm supposed to put backticks. Backticks. The font, yeah, so the size is slightly different, right? So the actual size here is slightly different. So what if I directly put 20 in here? Is it gonna change that much? Oh my god. Okay, open already. Thank you so much. Yeah. So what about 15? Yeah. What about 10? Yeah. We're very close. Maybe we should try to use that WoW font. Maybe it's a little bit better. So it feels like the TTF is outdated one. And maybe that's the reason why it's not used on the original website. So what was the WoW one? And by the way, so we should ban null direct. I'm joking, by the way, we should not. I'm joking. I'm not banning anyone today. Right, I'm actually trying not to ban people. It's difficult sometimes because you motherflippers deserve it, but I'm trying to be a good person, okay? I'm trying to be a good person. Even though you all fucking deserve to be banned, I'm telling you. So here's the wolf. So I remember it was, are they called Acme something something? Because maybe they are, maybe they are. It's just like Grixel, it is called Grixel in CSS. Right, it is called Grixel in CSS. You know what, I don't trust the chat. Okay, I want to look into that myself. So I'm gonna do that yet again. I'm gonna try to hack the website one more time. Okay, so then we look into the font, and the font is Grixel Acme 7. We can try to copy the value and then go into the source and find, I mean, yeah, probably we didn't even have to. So here's the font. Yeah, it's actually like that, right? So it's called Grixel in the CSS. All right. Now I'm more or less confident in all of this. I'm more or less confident. So TTF, WOF, right? I have a feeling that. So do they have Y? Yeah, they seem to have Y. Is there a Y anywhere in here? We can try to change that. Your mom. Okay, so Y seems to be correct. This is like a fresh new Y. So that means the TTF font is outdated. TTF font is outdated. Raylib. Do we see Scheisse? No, it's an old one. It's still an old one. And this is where the trouble comes in, right? Even though we have Wofen here, right? And I keep refreshing. Though, ooh, this is interesting. So we have to take the capital one. So what if? Yeah, okay, I see what's going on. It's still doing that shit. So there is a huge discrepancy between like a font that is used on website and the font that is used in there. So we'll have to do something about that. We'll have to do something about that. For now, what we can do is maybe have some sort of a factor that adjusts all of that, right? So we may try to have some sort of a factor. So if I just set font size, if I just set the font size, it's obviously gonna change, but we can multiply it to sort of like account for all of these things, right? So maybe 75 or something. So if we take a look at the core basic window, right? So it's kind of centered. It's kind of centered, but it's way smaller. It's way smaller than whatever we had in there. So maybe we can basically eyeball it. Right, what about 6? Something like that. 0.6. Looks good. Yeah, congrats, you created your first window. So it's a hack. It's a hack for sure. But we ported one example in here. We kind of ported one example in here. And because this factor is baked, right, it's sort of kind of baked in there. So the other examples that use the same function may work more or less correctly. They may work more or less correctly. So let me see. So maybe let's factor it out. Font size factor, right? Font size factor. So note, we are not using the same font as in the Raylib itself. We stole it from the website. So from the website, and it's slightly different. We stole. Let's put it this way: we stole the font from the website https://raylib.com, and it's slightly different than the one baked into Raylib library itself. To account for the differences, we scale the size with a magical factor. We stole the font from the website, and it's slightly different than the one that is baked into Raylib library itself. To account for the differences, so we scale the size with a magical factor. So maybe it would be better. It would be nice to have a better approach, but I don't know which one. So as of right now, I don't know which approach would be better. So I'm gonna leave it as it is right now. So now we can try to take a look at some other examples that use these functions like draw text and everything. So I think there was another example like core controls that test controls and stuff like that, and they do use the same like a draw text function. I want to see how that example will work with this function, right? And whether the factor is good enough, right? So maybe more examples will help us to adjust these things a little bit better, that specific factor. Right, and of course, I don't consider that to be a final solution, right? So it's just like, it's a stopgap, right? So what we need to do, we need to keep moving, we need to keep implementing functions, right? And the more functions we implement, the more we explore the internals of Raylib and stuff like that, the more information we gather, which potentially may help us to make better decisions and stuff like that. So we're doing recreational programming in here. We're not rushing a product to a market. We can just afford to do that. We can just afford to explore and stuff like that. And that's basically the gist of my channel, by the way. It's basically the gist of my channel. Just a pile more data to approach the correct layer. Exactly. We're literally training this model. This is one of the parameters of this model, right? So this is like a manual learning instead of machine one. So it's funny that some systems before the AI boom and stuff like that, some search engines, they quite often had like shit ton of different regexes to account for some special cases and stuff like that, and they may have like a separate module specifically dedicated to regexes, and those regexes were modified manually and stuff like that. You can view like this spaghetti of different regexes as just a language model that you adjust manually, right? It's not that different from automatic adjustments, just like you do that manually. It's kind of fascinating, isn't it? Right. So that it only recently occurred to me that you can view your code, your source code, as a model that you train manually, that you tweak parameters of which manually. That's a very interesting view on the code, and that I think it's like actually close to truth, right? So we're basically meta optimizers of this model. Can ChatGPT write valid regex? I don't know, can it? I don't use ChatGPT daily. So we get some subs. Thank you so much, Grappas, for tier 1 subscription. Thank you. So I could use ChatGPT, but so I had to create like a foreign SIM card, right? So then I have to have VPN. And to be fair, ChatGPT doesn't give me that much of a value to justify the hassle of setting it up for me, right? I used ChatGPT like a little bit through different proxies and stuff like that. I kind of get the idea of what it can. Right, I can see the value for some people in there, but for me personally, I can't see the value of that thing for me personally. It's just like, it doesn't help me with what I do usually. It doesn't really help me with what I do usually. Or maybe it helps a little bit, but not significantly. So I can't see how we can incorporate that into my workflow. So that's why it's just like I don't use it. All right, so let's go ahead and port another example. So I think I'm gonna just go ahead and literally commit whatever we already have, because I think it's cool and all. Is there any license for the fonts? We don't really need TTF license to do add the Grixel font. I don't know if it's called actually Grixel, right? So it's called Grixel in CSS, but it's not called like that in the font file. So I don't know. Add the license of the official Raylib font here, right? So this is going to be the to-do. So these are the examples. Let me see. So I have a lot of garbage in here, honestly. Can I do git ignore? So maybe we could build everything into a separate folder, so to speak. Could we build everything into a separate folder? That would be actually kind of cool. So here are the examples. You know what? Maybe I should create a shell script. Build sh. Right. Let's create a shell script. And in here, right, in here, we're going to be doing something like this. So this is that. But first of all, we're going to create the build. And we have includes in here, and we're going to put that into the build, right? So this is the first thing. And then we're going to have the game itself, but the game.c is located not in here. I want to put it into the examples folder because I want to reserve examples folder specifically for the Raylib examples, right? So this one is not really a Raylib example, it's my personal one. So yeah. So yeah. Where's my another make file? And in here we just build this thing. So these are the other things, right? These are the Wasm. And maybe we can factor out this stuff to a separate function, so to speak, so we can call it for a list of the list of the files, right? So then I'm gonna make it executable, and I'm gonna just rebuild this entire thing and see. So game frame, I forgot to do that. Yep, that seems to be working. And one of the things I like to do, by the way, is also enable tracing, so I can see what commands are executed in here. So as you can see, we can clearly see what is executed, and it's just like pretty cool, pretty cool. So let's remove makefile. Let's remove makefile, and in the README, I'm going to replace this thing to build sh. So that's going to be the thing. So the reason why I was making the build thing, is that now it is super easy to git ignore the build completely, right? So it didn't really do that, right? Because it's supposed to put this thing in here, right? So we git ignore that. We don't need that. So examples, they only contain that. The fonts contain that, right? So that's fine. So for the Raylib, maybe I should actually create something like lib in here and put Raylib in here, right? So I think I want to commit it into the repo so people can just sort of test it or something. I think that would be a good idea. So it's basically breaks the build script, but we can go ahead and quickly fix that, right? So now -l has to be lib. And in here it also has to be lib. So I think it's kind of important to just be able to build the same C file into both WebAssembly and a binary thing to sort of prove that it's portable, right? So you can actually port that. So because of that, we need to have a copy of Raylib in here. So let's go ahead and do that. And okay, so that seems to be working. So we deleted that. So we modified this one. We added that one. We modified this thing. We edit face, we did that, and I also commit Wasm because I'm also deploying this entire thing to GitHub pages. We're also deploying that to GitHub pages. By the way, speaking of GitHub pages, I think they're broken now. If I go to, why is it so slow? So in github.io, Raylib.js. Yeah, they are broken now. They are in fact broken now. And because it cannot load, yeah. So that's bizarre. So it's trying to load Raylib.js, which is the name of the project, right? And if we take a look at this entire thing, so we're loading /Raylib.js. So, and I didn't write that code. So the first pull request broke prod server. Literally broke prod server. Right, so classic. I wonder if that will fix it. I think that will fix it, right? That should be everything essentially. So we want to also clone that. We not clone that, but commit that and that. And that's basically everything. Right, so maybe eventually I'll move game.c like to somewhere else, right? So as soon as we have more examples, game.c is not going to be needed, right? So the examples are going to be like the demonstration of this entire thing. Right, so let's go ahead and say port core basic window to Raylib.js, right? So and let's push that right into the repo and see how it goes. So where is Raylib.js? So does it look good? Does it look Gucci? Tamaguchi? So includes contain the headers for Raylib, fonts, examples, lib, and stuff like that. So that's pretty cool. Okay, so let's go ahead and port another example, right? Something more substantial, because this is basically hello world. There's nothing particularly interesting in here. So let's go to visualizer Raylib src, and so we don't have examples here. Okay, so I was downloading the examples from a different place. Okay, custom frame control, custom frame control, basic window, custom logging, drop files, basic screen manager. Is it interesting example? Press enter or tap jump to play to gameplay screen. Huh? Is that screen manager? So how many things does it have in here? Does it have shaders and shit? I hope it doesn't have shaders. I hope it's super simple. Okay, press enter, draw text, draw rectangle. This is ideal. Right, so we have draw text, draw rectangle. We already have these two things implemented. No, we don't have draw rectangle. This is something that we'll have to implement. So yeah, that's pretty cool. So I'll go ahead and take that. So we're gonna try to port these things specifically. Let's just put it in here. Basic screen manager. So query replace core basic window and basic screen manager. So there's two things, and I'm gonna compile only native one, right? So we're compiling only native one because I want to see what this is going to do. Right, so then I'm gonna do core basic screen manager. All right, wait, press enter. Oh, it's just, okay. Press enter or tap or jump to ending screen. So it basically goes through different screens. Okay, that's cool. So that's actually a substantial example. That's actually a substantial example, I think. That's pretty cool. Right. So now let's basically copy paste this entire thing, and I'm gonna query replace this one more time. And we're gonna rebuild that for web as well. So we're building that for web. Okay, that's cool. And let's go to raylib.js, specifically the file, and let's replace this stuff. Basic, what was that, screen manager? Okay. So it's actually pretty straightforward to add a new example, right? So you just copy paste a bunch of things. But I mean, if you know how to do that, right? So for new people, it's probably not particularly obvious, but yeah, let's go ahead and just refresh and see how it is going to go and what kind of functions does it need, right? So it will tell us what it wants. Window should close. Well, we have to first, yeah, I completely forgot. We have to modify the entry point, right? We need to modify the entry point. So example, basic screen manager, and essentially, yeah, we need to move this entire thing into the game frame. Right, so let's go ahead and do that. That should be pretty straightforward. Game frame void. So, and I'm taking the entirety of this thing and replacing it with game frame. That's the game frame. That's the game frame. And now, if defined platform web, we set Raylib.js set entry game frame. So we just do that. Otherwise, we do our usual thing. Unload all loaded data, texture, fonts, audio here. But we didn't really load anything, did we? I guess it's a template or something. Yeah, I guess it's a template. And just end if. So that's basically it. So I'm not sure how well it is going to compile. Yeah, it didn't compile. Because it needs to have a screen width. By the way, this one is interesting. So there's extra stuff in here that is not needed. So it has these things. We can move them to here. Right, we can make them global. I don't really know why they're not global already, but now they are. So use of undeclared current screen. Where is the current screen? Where is it defined? Am I going crazy? Okay, so it's defined in here. So that actually requires moving all of this state to here. Right, it requires moving all of this state to here. So we'll need to think about how to not require modification of the entry point, because I remember that mscripting like had, you know, asyncify. Maybe we can do something with that as well, right? So, but that's going to be on the to-do list. All right, so yeah, we don't have these functions, so it would be better to actually declare it somewhere. Core basic, where was that? Game.c. Let's actually put it in there. So let's put it in there. All right, seems cool. Seems cool, seems cool. Now, if I try to refresh this entire thing, it already fucking works. Wait a second. It already works. Wait for 2 seconds. Then it goes away. And essentially, it already has everything to implement all of that. It just doesn't have a draw rectangle. What the fuck? It just worked, right? Like the beginning of this thing worked. So let's go ahead and implement draw rectangle. That's actually so cool. That's actually so cool. All right, all right. So draw rectangle. Raylib.h. Where's .h? Do I have .h? Draw rectangle. So obviously, like something is still wrong with the parameter, so we need to still, you know, change it a little bit. Draw rectangle. So this is a draw rectangle, and I might as well just copy paste this entire thing and just like put it in here in a comment, because I think it's useful. So we have position X, position Y, width and height, and the color, but the color is going to be just a pointer, right? The color is going to be just a pointer. So now we need to extract the color out of this entire stuff. So let me put that stuff in here. We don't need text, right? So we take the buffer, we take the color and stuff like that. So, and now, now we can set the fill style to the color, and then we can fill rect. Chat. Do you feel rect? Oh, oh. Sorry. So let's actually check the, you know, the linter, right? Can I check the linter? Use event declare. Okay, so hey, that's actually very useful. Thank you, Strager-sama. Thank you. Really appreciate that. It's actually very useful. Damn, that's actually super useful. I like this linter. And especially like that it's just like a single fucking executable and it's just so fast, and it's like, yeah, you can quickly check for some stuff before running it in the browser. So I really like that. Okay, so let's go ahead and do that. Boom. It just works. It works exactly like in the original. Well, I mean, the fonts are scuffed a little bit. And we also need to check whether the key was pressed or something. But here's the cool thing. Here's the cool thing. So the way Raylib works, it's not event-based when it comes to input. It checks the input each individual frame, right? It checks the input each individual frame. And essentially what we have to do, we have to add event handlers to the canvas and basically collect what keys are pressed. And on each frame, and we know when the frame begins and the frame ends. On each frame, we have to look whether the key was pressed and answer yes or no. And then when the user calls and drawing, and by user I mean the programmer, we clean up the list of already pressed keys. So we basically keep collecting the pressed keys into list, into the set, and on end drawing we keep cleaning it up. That way we know what keys were pressed on which frame, and then we can answer to the user, is key that pressed or is it not, and stuff like that. So that's how Raylib works. It's not event based, it's basically asked what happened on that frame, right? And it's the same with mouse events, right? So it doesn't wait for events to come in, it asks what's the position of mouse on the current frame. So were any buttons of the mouse pressed on the current frame? And it's actually a very interesting paradigm, and it fits well with immediate UI stuff. It just polls. Yeah, it's basically polling, right? So I think that's the official name for this thing. It's basically polling, roly polling. So we just need to organize that, essentially. We just need to organize that. And does JavaScript has any sort of like sets, right? Does it have any sets? Man, I like that it just works. It feels like I'm implementing like a virtual machine, right? So I'm implementing Raylib emulator. So there are some sets. Okay, so let's actually Google that. All right, JavaScript set. It's very hacky and it's not applicable to any Raylib application. But if we manage to implement the 2D API of Raylib, this thing already will be immensely useful, I think. Right, if you have a very simple game that uses only 2D Raylib, it would be super easy to port it to web like that. Right, if it doesn't use anything like super fancy like shaders or anything like that, but even shaders are portable to this approach. Even shaders are portable, I believe. Right, so if you start going into WebGL and stuff like that, and WebGL stream actually might be an interesting topic that I could do for views and stuff like that. So yeah. I think we're onto something. I think I can milk this thing. Even if this thing is not going to be useful generally for anybody, I'm creating this thing for myself, actually, because like I don't expect anybody to use that, because I'm pretty sure everybody's going to just use mscripton, and that's fine. That is totally fine. But when I'm going to be using, when I'm going to import my Raylib applications to web, I'm going to be using that. I'm definitely going to be using that, and I'm going to just simply implement only the API that my application uses, and I'm going to just like keep maintaining, maybe keep adding more functions and stuff like that. Right, because I like to be in control of my dependencies. So I like to be in control of my dependencies. So yes, sets. So you can just do set. Objects are collections of values. A value in the set may only occur once. Okay, that's understandable. All right, so let's create a set. So what do we have in here? Let pressed keys. So how do we check that? Do we check key down or key up or something like that? So if I go to basic, is key pressed? What constitutes a press? Right, what constitutes a press? Oh, when you hold it down. Okay, so it's called pressed, and there's also release. Okay. Pressed keys, new set. So I suppose we just do that. Is gesture detected. So what's funny is that maybe if we're gonna return something, so gestures, what is a gesture? Is it like for mobile stuff? It could be for mobile stuff actually. Check for gesture have been detected. So it's a touch handling. We can also support that. Believe it or not, we can also try to support that. Right, because web browsers do have the like a gesture API and like a gesture stuff, right? So they do have it. Okay, so let's go ahead into Raylib.js, and in a canvas we have to add event handler. I don't remember how to do that. Event handler key pressed. Again, I'm not a web developer, right? The key pressed returns true if the key was pressed, was not pressed the last frame and is pressed this frame. Okay, so they basically making sure, right, that the definition works even if you, the implementer of the API, also use the polling, right? But we're not using polling, we're receiving events, right? So for us, checking that it was pressed is pretty easy. Did we receive the event? Yes, that means it was pressed, right? So we're not using polling, so for us it doesn't really matter that much. So key press, all right, key press. Console log key press e. All right. So add events. Is it events handler? No, it is not event handler. Event listener. Okay, I think I'm actually a little bit tired already. I'm already getting a little bit tired. I'm sorry. I have a lot of shit opened up, by the way. Yeah, there we go. on key, I suppose maybe on key press, maybe. What was that? Key pressed. So that's bizarre, isn't it? Add event listener key press E. So that should work. Let me close all this shit. Like it's just too much. I keep forgetting where was the thing that I was working on. Right, localhost. Maybe I should also make a small break. Okay, open it, please. Maybe because it was deprecated. Is there any notes? Usually web browsers show notes when something deprecated or something like that. We can do key down, right, if that's something. Okay. So JavaScript key down event. Why is it you show me Russian websites? That's just like really not useful. Needs to have focus. How can I make it focus? You know what? I think I want to make a small break. Right, because I'm also losing focus. So, and after the break, we're gonna continue. All right, so let's actually straight up Google up how to, you know, handle key events in a canvas, right? So I think that will be actually useful. Key events on canvas, HTML5, JavaScript, and let's use Google. Right, so there's probably like a complete example. Best way to create key, create handle or listen. Google, don't be okay. Create. Apparently, we're doing create. Right. So on a window. All right. So that makes sense. Maybe we should have actually done that on a window. Sure. So this is a key down, and we just do the usual thing. Okay. Okay. Let's see if that's going to solve any of our problems. Right, so it does in fact. Okay, so I just had to do that on a window. That makes sense. That actually makes sense. So what we're gonna do is, do we have pressed keys in here? Maybe I can make it a little bit bigger. Can you guys see everything? So we have pressed keys. All right. Yeah. So this is one of the advantages of having like these global variables like this, is that you can then just use them in a DevTools, which is extremely convenient. And then I can maybe add something. And what kind of stuff can we even add there? Right, so we can try to add the codes. So there is a code key as, but we are kind of interested in key code. Key code. So let's just go ahead and do that. So pressed keys. Add key code, and we are basically done, believe it or not. I would like to check the linter. Linter seems to be fine. And another thing I would like to do is when we end rendering the frame, can I do pressed keys clear? Right, is that something that exists? Compilation. Is that clear, or is it something else? Pressed keys clear. Yeah, it is clear. So, by the way, can quick lint thingy, how is it called? Quick lint JS, like handle things that don't exist in a set, right? So it doesn't check this kind of thing. Okay, so that's fair. So it's a little bit simpler than I thought originally, but I mean it's already pretty useful for what it is. I can see myself using it. It's probably gonna become better and better, so I'm pretty sure more stuff is gonna be added here. Is key pressed? Okay, is key pressed, and it accepts the code, right? Is key pressed? Is key pressed? I suppose key, and we can just check pressed keys. Why didn't you? Okay, contains has. Okay, pressed keys has key, and I suppose we can just return that. I suppose we can just return that. All right. So, and let's see what we have. Okay, is gesture detected? We can just put a stopgap in there. Is gesture? How is it called? Gesture detected. False. Detected identifier. Forgot a comma in here. By the way, it could be actually caught. Yeah, there we go. Missing comma between object and channel. This is actually useful. This is better error message than this shit. Yeah, that is already better error message than that. Okay, that's cool. Waiting 2 seconds. So what about enter? It doesn't handle that thing though. Right, it doesn't handle it. So what's the key code of enter in Raylib? So key enter is 257. And why is it 257? So, and in our case, the code Raylib.js is something else. We might as well actually log that yet again. Console log e key code. Yeah, key down. So this is a key down. Right, and let me see. So it's 13. Why is it like that? So do we even have 13 in here? So there is ASCII stuff. There is ASCII stuff, and there is these things. So this is space, and this is enter. This is space, and this is enter. I wonder if this corresponds to anything, or is it just like a random? Is it just a random? Where did they get that? It's an ASCII code for CR. Yeah. It's an ASCII code for CR. I wonder, like, what's the meaning behind this thing? It's GLFW. Let's explore the source code of Raylib, like literally. Maybe there, we can find some information about that there. So key, maybe we can start is key pressed, right? So we can start with this thing, because if there's some sort of a meaning behind them, we can exploit that. So max keyboard keys, right? If it's between that stuff, and there is a current key and there is a previous one. Okay, so that means somewhere in the code we set in those things. So how do we even set them? So let's actually find all of the places where we refer to this thing. That's quite a few places. All right, so core, I think this one is more interesting. So we just check stuff in here. So here we set it to true. Okay, this is cool. Play automation event. It's just automation event. So there's that. It's also automation event. So it's our core desktop. So this is probably where all of that is going on. Okay, key callback. Okay, so it comes from GLFW. All of that shit comes from GLFW. All right. So, and how do we set that thing? So this is key callback. There's a bunch of key callbacks. So this is web, and on the desktop. Yeah. So okay. So it's just straight up set as the key callback, and it's the same. It's the same thing, right? So they're completely dependent on GLFW. So GLFW key codes. GLFW key codes. All right. Keyboard key tokens. Is there any information about that? So we can even find key enter, and it's 257. Okay. Is there any information like what's the meaning behind them? So these key codes are inspired by USB HID usage tables, but rearranged to map to 7-bit ASCII from printable characters. Function keys are put into 256 range. The naming of the key codes follow the rules. The US keyboard layout is used. Names of printable alpha characters are used. AR3 blah blah blah. For non-numeric characters, Unicode blah blah blah. Keys that lack a clear US mapping, world X. For non-printable keys, custom names are used. So what we can do in here, maybe we should organize some sort of a mapping, from maybe even like a key code that we receive from the browser, right? We need to actually mimic the this kind of stuff in here as well. So let's actually print the whole event. So then, oh yeah, I'm supposed to actually say something. Okay, so in here we have a code, right? So for example, key S, and we can try to map these codes, these names, to the GLFW, codes, right? Because oh yeah, you just kind of would our core web not have to remap this? Yeah, so they compile like a web version of GLFW or something like that, which is kind of a little bit of an overkill, right? Because the browser basically has the functionality of GLFW. Browser is GLFW, right? It's just a different API, right? It's just a different API, and we're trying to use GLFW as the thing that abstracts away browser capabilities, but then Raylib is also the thing that tries to abstract away the browser capabilities. So even with such things as Raylib, we have layers and layers and layers of adapters to different APIs. So in fact, browser has so much fucking shit other than GLFW. Yeah, exactly. In fact, that's the reason why I'm trying to do this thing that I'm doing, is that because browser basically has all of the functionality of Raylib. Basically. So anything Raylib can do, browser can do that. So your job is just to rewire the capabilities of the browser to the API of Raylib. So yeah, you have two APIs. You just have to adapt one API to another one. And to do that right now with Raylib Web, you have layers of other things that also are supposed to adapt some other APIs to other APIs to other APIs, and it's craziness. But that's the world we live in, right? So that's the world we live in. So, and again, whatever I'm doing, I don't expect it to be useful for anyone except myself. So I'm making this thing for myself purely, right? So R, Control, Alt, etc. are modifiers in Raylib or just same keys? I don't know. You can look it up in here. Okay. So let's see. So if I press Enter, what do we have? So it's the key code. The code is Enter. So for now, we can do if E key. Can I just switch this thing? Is that something I can do? Key code case and just enter. I'm pretty sure you can do switch cases on these things. So pressed keys add 257, right? So it's 257. So what we can do, can we just have a mapping? Something like this, const GLFW key mapping, and we can do something like this, enter 257, and then we can probably add more, right? We can probably add more. So then we can do GLFW key mapping, and I suppose I can just do key code and add that to pressed keys. Emacs, don't be slow, please. Thank you so much, Emacs. Right, so for now we only have enter, but I mean, you can extend that if you want to. right, if you need to as well. All right, so waiting 2 seconds, and then if I press enter, didn't fucking work, bruv, it didn't work. Why it didn't work? Jesus fucking Christ, stop spamming. Okay, so the example seems to be working. So we just ported another example. It looks kind of a bit off, if you know what I'm talking about. Right, it looks a bit off. And so basic screen manager. Right, so yeah, so I suppose maybe it is too big, or maybe something is off. We could try to adjust that parameter a little bit. So 0.6, what if it was 55? Yeah, I need to open DevTools. Okay, refresh please. It didn't really help, so I'm really not sure where. Oh, I think I know what the fuck is going on. So the position is calculated differently. The position is straight up calculated differently, and I suppose maybe we have to add the height factor or something, like the size of this entire thing. So font size multiplied by 55. All right, and this is the font size, and we can also try to maybe add font size position to here and see if it's going to work or not. Yeah, that worked. That actually worked perfectly. Yo, what the fuck? So we also have click, and I don't know where the click is coming from. Core screen manager. I suppose it's coming from the gesture, right? It is coming from the gesture, but yeah. So yeah, we ported this thing. So that's so fucking cool. Isn't that cool? Like, we ported this thing and without them scripting, right? And so it's just like, wasn't that super hard? I don't think so, right? So it's around 6. Maybe it could be 7. Just a little bit. It's kind of weird that it doesn't use the you know, the size of the text to you know, align it properly, right? It doesn't use that. But yeah, that's cool. That's really, really cool. So we ported 2 examples in here. So far we ported 2 examples. So there's also a couple of but yeah, I want to go back to the first example. And what do we have in here? Right, so where's the Wasm? .wasm. So basic window, right? So we created a basic window in here. Congrats, you created your first window. Okay, so and go back in here. So it would be kind of nice to be able to switch between different examples and everything. Okay, so let's go ahead and commit whatever we managed to do. Right, so got that. Port core basic screen manager example. Right, I'm gonna push that right into the repo. So, and essentially the process of like figuring all of that stuff out is like that, right? It's like implementing a virtual machine. You take an examples and you just like, you know, mess with the thing until it works, then another one, and while doing all of that, you also gather a lot of information about like what other things you could do, or maybe you will eventually come up with a better approach completely and start over, right? But already with the knowledge that could help you to improve the whole system and make it better. So this is more like a research and gathering information. But again, this is the reason why I think it is doable, right? Remember how in the previous stream I said it's like a lot of work, but it is doable, right? So, and that's the result, right? And it's not like you can't use this thing until you fully implement it. So here's the thing. It is not fully implemented. That is true. But it doesn't mean it's useless. That's the thing. It doesn't mean it's useless. If you use only the functions that are already implemented, you can use this thing. So yeah. So that's already kind of useful, right? For some situations. And then maybe you have example that uses function that is not implemented in here, but it's a couple of functions. You can implement it and make this thing a little bit more useful. Then somebody else comes with a different thing and they implement a couple of functions and so on and so forth. You do more work, but you get less moving pieces at the end. There is an open issue now because of mscript breaking compiling for its new versions. Exactly, right? It boils down to the thing I was talking about predictability of the problems, right? So you use mscripting, you get problems that you don't know of, and you can't predict them because you don't control that dependency, right? So you're always gonna have problems. You're always gonna have problems, but you have to make a decision. You need to choose between the problems you don't control and basically play gamble all the time, or the problems that you're afraid to face, but you can control them, right? So in software engineering, like control over the situation is the most important thing, in my opinion, because if you control the situation, you can plan it. So, yeah. I don't know. So I don't know. So I'm gonna leave the project as it is. I don't know if I'm gonna stream more of this thing. My plan for this project is I'm gonna be looking into pull requests from time to time. If you have any pull requests or suggestions, so I can merge them or answer to them and stuff like that. And when the time comes and I need to port some application to Raylib, I'll be using that for myself. I do not recommend like using this thing for you, right? And I'm not saying that it's going to replace Raylib Web. What I'm saying is that it's an alternative research project that I do for myself. And if it's accidentally useful for you, well, that's great, right? And if like this thing is useful for you, but it misses a couple of functions and you implement those couple of functions, that is also great. So yeah, that's basically my conclusion on this sort of like journey of exploring web capabilities of Raylib. Maybe I will do more streams on that, maybe not, we'll see. So, and yeah, that's basically it. Implementing shaders with WebGL would be interesting. I do think so. I actually agree with that. So maybe it's going to be one of the streams that I could do. Right, because one of the layers that Raylib has is RLGL, right? So basically it ties together different versions of OpenGL, right? If you write a code that uses RLGL, it will work on several versions of OpenGL without like modifications and stuff like that. What if one of those versions of OpenGL would be WebGL? That would be interesting. So we can port specifically RLGL, and maybe all of the code that depends on RLGL will work automatically with that. Not everything, but yeah. So anyway, that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Mr. Zozin. I love you. Mwah.